Okay, we are recording. Alrighty, it is 9:30. Welcome everyone to our second computer science learning event. We had one in August, our kickoff, and we covered the 5 core concepts. So this time we'll be going into a little more detail on one of the core concepts. So next slide. So if you're wondering who are these two people talking to us, I am Janine Nakakura, resource teacher with the Office of Curriculum and Instructional Design. I'm helping out with computer science and distance learning, but I do have a background in STEM, secondary. Okay, and here is Faith, educational specialist in computer science, also at OSID. I'll let her say hello.
Thanks for joining us.
Next slide. So we'd like to start off with a bell ringer, and this actually has to do with our topic for today. So in the chat, if you could type, what do you do when your printer doesn't work? Okay, and I'm sure it's happened to most of us at one time or another, either at home or at work. So in the chat, could you type, what do you do when your printer doesn't work? Okay. Restart it, turn it off, turn it back on. Anything else? They call us, right? That's your job, tech person, right? Okay, but Clifford Neal, can we call you Clifford, or do we have to call you Clifford Neal?
Either
what
one
do you
is
hope
fine.
people do before they call you?
Turn off and on again, and
Turn
then
it
I'll
off, turn it on.
try it.
Okay. Someone,
Great.
when we practiced, one of our coworkers said, you know, call my son. And one of our coworkers, his mom always calls him. So okay, let's go to the next, Google the error message. Okay, good. Let's go to the next slide, which is the agenda. And again, I will put the agenda link into the chat as often as I can remember. All of our links should be in that agenda along with what we're planning to cover for today. Okay, so there we go. Next slide. So last time we covered the 5 core concepts. We gave an overview. So this time we're going to go into more detail into the first core concept, which is computing systems. I have to look real close because it's small on the slide. Computing systems consists of, sorry, I gotta take off my glasses for that, so small. Devices, hardware and software, and troubleshooting. Okay, so here is a real life example. This actually happened in our office about 2 years ago before the pandemic. And here's our printer, and it just stopped working. We couldn't print out anything in our office. So this is our administrator, Charles Souza, and he's a hands-on kind of guy. So he went down underneath and looked at the wires connecting the printer to whatever else it was supposed to be connected to. And he found out that when they upgraded our phones, just the other day, they did something where they disconnected the printer from the internet, which was in our phone. So we found out that the printer wasn't talking to anything in our office. So once he figured that out, he plugged the printer back into the internet, or got it connected, and then our printer was able to talk to the devices in our office. So that is an example of troubleshooting with computing systems. Next slide. So I'll turn it over to Faith now.
Okay, thanks, Janine. So as Janine mentioned, we have covered all of the core concepts in an overview, and today is computing systems. So the core concept is computing system, and the sub-concepts, devices, hardware, software, and troubleshooting. And these are the standards we'll cover today. So we included links to these standards at the bottom, and also a link to the K-12 progression chart, and a link to standards for computer science teachers. So if you were to open up that progression chart, this is what it would look like. On the very far left, the darkest colors are the core concepts. And to the right of that, a little lighter shades of corresponding sub-concepts. And then you can see the progressions going through the different grade bands. So how do computers work? We're going to listen to just a quick snippet of this video put together by code.org. And as you listen, try to identify what makes up a computing system.
Under the hood, all computers do the same four basic things. They input information, store and process the information, and then output information. Each of these things is done by a different part of the computer. There are input devices that take input from the outside world and convert it into binary information. There is memory to store this information. There's a central processing unit, or CPU, where all the calculations are done. And finally, there are output devices that take information and convert it into physical output.
Let's talk about input first.
Okay, that was just a short clip that gives us an idea of what is involved in a computing system. So if we take a look at this picture, I know these are, real traditional looking devices, but maybe if you could type into the chat any one of these that you think might be an output device. Awesome, yeah, the printer.
Printer. Monitor, printer display, monitor. 1 plus 6 plus 2. No idea what 7 is. Modem.
6 plus 2.
There's a little key to the
Wow.
bottom left. Yeah.
Super, super. Okay. Do you think there's such a thing as an input and output device? And if so, do you think any of these might be such a device?
Which of these could be input and output? Trick question. Not really.
Oh. Uh-huh.
Anybody want to venture a guess as to which one of these 1, 2, 3, 4, 5, 6, 7 could be input and output? And today any of these could be both, depending on how it's wired up. Number 2. Where's number 2?
Oh, reaction. Oh, I love these ideas.
Same with his mouse. There is no right or wrong because obviously these are old. This is an older picture.
Yeah, and I had to actually do some research on the modem because I wasn't really sure what that was. But I mean, how to describe it in terms of input output. And according to Techopedia, they said the modem is one of those input output devices because you can send data in and sends data out. So yeah, thanks for participating. Great answers. So here's an activity that students can do by Linda Lucas. She is an author, illustrator. Let's get that video queued up. Oops.
There are many
Okay, for some reason, this particular video gives me the spinning wheel. So I'm going to ask Janine if she can
Okay.
different ways to put information into a computer, like the keyboard or a mouse. These are called input parts. Other parts allow the computer to send information out, like the monitor or a printer. They are known as output parts. Some parts can be both input and output. Cut out the input and output devices. Can you figure out which is which? What about making your own new input or output device for the computer, like a mouse, a video camera, or VR headset? Input and output, or I/O devices, are the pieces of hardware used to communicate with a computer. You can think about computers as devices that process information through input devices and show it through output devices. When taking a photo, the camera recognizes your face. That's the input data. Then there is a piece of code that processes the photo and maybe adds a filter. And finally, your photo appears on the screen. That is the output.
Okay, so that might be a fun video or activity you could do with your students. And I'll share a little bit more about Linda Lucas. She has written 3 books, and they are all called Hello Ruby, her Hello Ruby series. And this particular one is Journey Inside the Computer. And in this story, little Ruby has a huge imagination, and she's bored, so she goes to her father's computer, and she realizes that she can't find that cursor. So she talks about it with Mouse, and they decide to climb into that little hole on the side of the computer to go looking for cursor. And she tumbles into the computer and finds all the bits that are turning off and on. She sees the central processing unit telling everybody what to do, and she finds the RAM and ROM storage. And then finally, she goes through a sequence of steps to troubleshoot, and she figures out where the cursor is. On the back of that book are about 25 different exercises and activities that students can do. And this is one of them, of making their own paper computer with all of the elements drawn out here. Another option students can do to make a computer is a Piper kit. And here is our administrator and our colleague, and they're following the blueprint that comes with the kit and putting all the pieces together to make a computer that actually works. And this was such a neat activity, but you must consider that all these little screws and little pieces might be something to think about the management of it. Then we visited Mokapu Elementary, and they have a Girls Who Code club after school. And their facilitator, Adrienne Ulu Vincent, saves old computers and laptops on campus, and she allows her students in the club to open up the device, take a look at all the pieces, pull them out, get a closer look, and they just love that hands-on activity. So we've been looking at computers and devices maybe more in a traditional sense, but if we think about how far computer systems have progressed and what they might look like now or into the future, and is it possible that computers might eventually take over the role of the human? So let's take a look at this short video, and maybe Linda can give us some ideas about those questions.
Computers are everywhere around us. You probably have over 100 computers in your house, because computers are not only the desktops and the laptops, and they are not defined by the screens anymore. You can find a computer in your fridge, in your toothbrush, and in your teddy bear. This generation of kids will be the last one to remember the computer as the glowing box. So I have here a few pictures. I have a picture of a car, a book, a grocery store, a camera,
and a mobile phone. Guess which one of these is a computer? Well, all of these are computers because, for example, a car has a navigation system, which is a computer. And a grocery store has all sorts of computers inside of it. They have burglar alarms and cashier machines, and even the ice cream box that keeps the ice cream cold is a computer. If you ask your parent how a computer actually works, you'll probably get a blank stare. Inside the computer, there are a lot of small components. Each one of them has a special role. Computers are built with hardware and software. The electrical or mechanical parts of a computer are called hardware. The instructions and the programs inside the computer are the software. Hardware and software work together to run a computer. So first we have the CPU. It's very good at bossing everyone else around, but it has a hard time remembering things. The CPU is extremely fast at calculating things, but it has a very hard time remembering things, so it needs the help of the others to remember. Next, we have the GPU, the graphics processing unit. It's very similar to the processor, but it focuses on things that are shown on the screen. Next up, we have the mass storage. If you have something that you want to remember for a long time, like your family vacation photos or your game levels, you need mass storage. The bad thing about mass storage is that it's extremely slow as a memory type. And this here is the RAM, the random access memory. It works furiously between the mass storage and the CPU, delivering all of the immediate information and working as a quick memory between the two of them. But when you close the computer, the RAM forgets everything. And finally, we have the ROM. The ROM includes all of the information that you don't accidentally want to delete from your computer, like the instructions on how to open up the computer. Computers might look smart, but all they do is calculate. Computers run a huge amount of simple calculations one after another, but they would have a hard time understanding that for humans, heart means love, and they wouldn't know what love feels like. Computers don't come up with solutions on their own. They need instructions. People, on the other hand, can think creatively and independently. That's why we make such a great team.
Okay, so that was Linda Lucas talking about what computers could look like as we look into the future and our role with computers as humans. So you could have a discussion with your students about which of these were computers 10 years ago or could be today or even 10 years from now. So let's take a look at this picture on the left. It's human neutral neighborhood. And do you see things in this pretty typical neighborhood that might be running on computer systems? Maybe type in the chat some of the things that you notice that might be running on computers. Definitely camera, stoplight, ATM, the washing machine, for sure. Yeah.
Washing machine. I didn't even notice there was one in the picture.
Yeah.
Good
it's in
eyes.
that little shop
Yeah.
window.
Good
Yeah.
eyes.
Pedestrian lights. Absolutely. Automatic doors, sliding doors. Yes. Oh, very observant. The Xbox.
Xbox. Where?
Headphones.
Oh,
All in the little
goodness.
shop window. Yeah. Super observant folks. Yeah. So, and I was even thinking, that door, the sliding door right now, it's sensitive to if a person, were to step on that weight pad thing. But what if we could make it so it could take your temperature too and decide whether or not it wants to let you in. You know, if you have a fever, it might not open up. So definitely in a typical neighborhood, and as you walk around your own neighborhoods, take notice of all the things that run by computer systems. And another example is our smartphone. The picture to the right, that is a little computer in and of itself. So what if we ran in the store before it closed and I was hot and it didn't let me in? Yeah, well, it's a thought, but I'm sure they have to think through all of the different scenarios.
But temperature too is internal, right? So if your body is working properly, it should still have a normal body temperature, even if you were exercising. Sorry, biology teacher here. Homeostasis.
Yeah, so I would encourage you to invite your students to take a look around the neighborhood, look in their homes, look in their bags or anywhere. Shane talks about look in your pocket and purse or pocket, and there's everything pretty much around us that runs on computing systems. So in terms of troubleshooting, the last standard that we wanted to address, we've compiled some articles here that we thought were kind of easy to follow and helpful. And so I'll just share one of them with you. So general tips to keep in mind: always write down the steps as you're troubleshooting, so that, if you want to backtrack, you know what you already did, or if you want to share with somebody how far you've come along and what you tried, it's all there so you don't forget. And make note of error messages that you see, because those are helpful. And a process of elimination. So here's a scenario where the printer doesn't work. Talking about full circle back to the beginning, that question that Janine asked. And so
and there's check the cords there, like people said.
Check the cords. So just going through, just like little Ruby did, just go through that series of steps, keeping track of what you did and didn't do, and coming up with solutions and simple solutions to common problems. So we hope these articles are helpful to you. So these are the standards that we covered, once again, just to come full circle. And if you want to access that Hello Ruby book or any other book in our statewide ebook collection, here's the instructions to visit soraapp.com. And another example of a book you will find there, What's Inside My Computer. And this might be for a little older students with actual photos of the pieces or parts inside. The last thing we shared this video with you is kind of a timeline of computer science in Hawaii DOE. And if you haven't seen it, I invite you to take a look at it. It kind of records what we have done in the last 3 or so years and where we're going in the 3 or so years to come, and how computer science needs to be offered at every school 3 years from now. So I'll turn it back to Janine.
By the way, there's a really good tip in the chat. Clifford Neal says he takes a picture of the error message. That's a good one, because sometimes the message is so long. So sometimes it's good to take a picture and show it to your tech person, like Clifford Neal, right? Like, this is the problem. This is the message I get. All right. Really good tips. All right.
Yeah,
so back to the slides. We have Digital Citizenship Week coming up in October, from October 18 through the 22nd. So the national events are in that link. It's underlined Digital Citizenship Week, and that's Common Sense Education. They have a wealth of resources. Sometimes it can be overwhelming because they have just so many good things that are free. So where do you start? So that's where we come in. So think of us as your filter. We will filter through all of the great resources and show you what might be a good place to start. So we will be doing an asynchronous recorded session, And we will put the slides and recording here and in the learning event flyer after October 7th. Okay, so we will make a recording, just tell you where to start, you know, how to filter through all of the good information, and hopefully help you get started with digital citizenship and have something for the week, maybe at your school or in your class. Okay, next slide. Additional resources are here. Faith compiled an elementary video and some secondary videos. Sometimes we focus more on elementary, sometimes we focus more on middle, sometimes we focus more on high school. So each of these learning events, you know, we will focus on a particular grade band, but we will try to have resources available for all ages and grade levels. Okay, next slide. Door prize time. Okay, we have 4 more minutes. So last time we said whose name was closest to Byron, because Ada Lovelace, one of the first computer programmers, her father was Lord Byron. So for this one, we're kind of gonna do something similar but opposite. So if your name is closest to Linda, okay,
Oh,
not
farthest.
closest, but farthest. Is your name farthest from Linda alphabetically? Okay, put it in the chat and you will win a prize. We will send it to you through Armored Car. And I'll type it in the chat. So is your name farthest from the name Linda? If you're a visual person like me, and you're like, what did she just say? Okay, it's in the chat. Is your name farthest alphabetically? Alphabetically. Farthest from Linda. Steve. Okay. Anyone else? If you think your name is the farthest alphabetically from Linda, and Steve, can you tell us why you think you're the farthest from Linda alphabetically? Alyssa, and Alyssa, why do you think you're the farthest? We might have a tie here.
Oh, I'm not saying that I'm farthest. I'm just hoping that I'm the farthest. I'm farther than Shane.
Farther than Shane. You are right. So Shane is
I love your
missing.
spirit.
Alyssa, can you give us some evidence as to why yours is farthest from, and I don't know the answer. Shane is from Toronto. No, Linda is from
It's the
North.
name, not
Finland. Alphabetically. Well, if we made a list of names alphabetically, I'm going to look at the list of names here. And L is sort of in the middle, right? A, B, C, D, E,
kind
F,
of in the middle.
G, H, I, J, K, L. L is what, number 12? I'm trying to do this systematically. And Alyssa is way up there on our list of participants. So Alyssa says, if I is in the middle of the alphabet, A is on the outermost point. What is the middle? Is K the middle of the alphabet? I think it's K, right? 13?
KL M.
L, M, N, O, P, Q, R, S. Well, you know, Steve is like 8 letters from L.
M and N
Alyssa
over
is
the middle.
A, B, C, D, E, F, G, H, I, J, K, L. I think like 12 letters away. So I think it's sorry, Steve. I think Alyssa is our winner. Alyssa, could you tell me what school you're from? And I will mail you. And can you tell me what you want from our door prize? A water bottle, earbuds, or a notebook?
Iolani, yay!
I will
Students
send it
out
to
there.
you. Iulani. And what is your choice? Water bottle, notebook, or earbuds? And I will send it to you. Otherwise, I will just randomly send one to you. M and N are in the middle. Alyssa says M and N are in the middle.
Yeah.
Down for anything. Okay, I will surprise you, Alyssa. Maybe you will find even more than you thought in there. Okay. Well, thank you, everyone. It's 10 o'clock. Thank you for joining us today. Please fill out our feedback form. We will put the link into the chat, and it should take you 1 minute. And this will help us make our learning events even better. Yeah, Shane, the Piper Kit's
Sorry.
not there yet. Maybe it will be there in the end of the year grand prize sweepstakes award.
But thank you for your participation and sharing of ideas. I love this learning community and we all learn from each other. And so we really appreciate your attendance and participation.
Okay, wait, I'm having a hard time. I'm going to turn my camera off because I can't, it's slow loading the link to the chat. Can somebody put the link to the feedback form in the chat if they can? Sorry, my computer is running slow right now. I will try to get it. Okay. And I will also send an email to all of you who have participated and give you any links and recording links and whatever else you need and a thank you. But it will also be in the flyer. So the flyer is your one-stop shop. So if you missed something, you know, go to the flyer. It will be in there eventually. Okay, so here's the feedback form. And we thank you for attending, and we will repeat this in the afternoon with different people, hopefully. So I will stop the recording now. Stop the recording. Stop.